Hey everyone, we're going to be talking about magnetism and electromagnetism in this unit. When you think about magnetism, the first thing you probably think about are magnets. We're going to talk briefly about magnets today and then move into the main topic as we go along of the relationship between electricity and magnetism. Okay, so first of all, magnetism is just, we know that magnets exert forces on one another, and these forces are similar to electrical forces, like a positive charge attracting a negative charge. The North Pole attracts the South Pole. Right? They can have attraction and repulsion. Attracting, again, are opposite poles. Repel are same poles. Right? And the strength of their interactions depends on how strong, first of all, how strong the magnet is, and then the distance between them. But we're not going to have a Coulomb's law equation for magnetism like we did for charges. Okay, so we know that magnets have polarity. Two ends are called the north and the south, as opposed to plus and minus. We know that like poles repel, unlike poles attract. And some metals can be polarized when we bring them near a magnet, and they become temporary magnets. Like, for instance, I have here a few paper clips that I'll put in my hand right here. A few paper clips that I'll put in my hand. You can see those. Whoops, let me make sure I can see it. Paper clips right there. All right. And I'm going to take this paper clip, and you see if I touch them down there, they don't attract anything. But now I'm going to take this magnet, now I'm going to touch it to there, and suddenly those paper clips become a magnet. But then when I remove it, take it off, they fall back off. All right, so they only become a temporary magnet. They become what we call polarized. And only certain materials can do that. Things like iron and steel, and sometimes nickel and cobalt. I'm not going to worry about those two pages right now. All right, we know that magnets are surrounded by a magnetic field. Right, much like charges are surrounded by something else, electric field. Well, we didn't get into that, but we're going to talk about magnetic fields here. Right, field lines basically spread out from one pole and give around the magnet to the other pole. If you probably remember doing something like this in middle school, where you used the iron filings around a magnet, you might have seen the magnetic field. Right, so field lines go from the North Pole to the South Pole. Take a minute and draw this in your notes. Okay, it doesn't have to be a perfect drawing, but draw something along those lines. And you can pause it if you need to. All right, when two magnets are brought close together, their fields will interact. So you can see here, if I have a North Pole and a South Pole, between them you see we just have the field lines kind of connecting the two. But if you have two norths or two souths, notice they kind of push away from one another. Again, take a minute and sketch both of these pictures so you kind of have a feel for what the field lines look like. Compasses, compass gives you the direction because they line up and they show you the field lines, right? So in this particular case, if I put a compass here, and all a compass is a tiny magnet, and those tiny magnets will line up with the field lines, right? And you notice that they go in the direction. If you're using them outside on the Earth and you're using a compass to kind of find the direction, it's lining up with the Earth's magnetic field so that it's pointing towards the north. The next topic we'll cover is the relationship between moving charges and the magnetic field.